put two of them on a spacecraft, you get about 40 or 50 kilowatts of power. That will enable you to do exciting missions like the asteroid redirect mission.
With Proxima Centauri, the nearest star from Earth, a staggering 40,208 billion kilometers away, and Mars requiring a minimum of 5 months of travel, the challenge of distance has long plagued space exploration. However, Musk and NASA's latest innovation promises to redefine the possibilities. Imagine reaching Mars in weeks instead of months. What is this new space innovation? And what does it mean for the future of space travel? Join us as we delve into this cutting-edge technology that the USA and Elon Musk have just revealed. A light-speed engine that challenges the laws of physics. Collaboration with NASA.
SpaceX is a big partner on this project. We need them to be successful. They need us to be successful. This is a great partnership.
The Mach 2 parachutes, we think those are safe. Green parachutes are possibly 10 times safer.
As Musk seeks a faster mode of transport, collaboration with NASA emerges as a potential solution. This partnership, characterized by their previous collaborations in space endeavors, such as Musk's involvement in ferrying personnel and cargo to the International Space Station, extends to the ambitious Starship project. NASA's vested interest in Starship as a lunar lander for future moon missions is underscored by a substantial financial commitment, approximately $3 billion. It is, therefore, unsurprising that Musk and NASA are pooling their resources to explore the potential of the Speedlight engine for achieving exceptionally rapid space travel. What sets the Speed engine apart is its impressive speed and unique ability to operate without the need for traditional fuel. This may sound like a revolutionary leap forward, but historical context reveals that propulsion without fuel is not entirely new. In the late 1970s, American inventor Robert Cook proposed an engine that converted centrifugal energy into linear motion. Subsequently, in the early 2000s, British inventor Roger Scheuer introduced the M-drive concept, which claimed to generate thrust from trapped microwaves. Despite these innovative ideas, both remain unproven and are generally regarded as impractical, as they seemingly defy the fundamental physical principle of momentum conservation. But the new NASA and SpaceX engine is here to change the tides. The helical engine, propelling beyond limits. The newly developed helical engine, also known as the Speedlight engine, showcases remarkable swiftness in its operations. Boasting an impressive velocity of 300 million meters per second, this propulsion system's capabilities are truly noteworthy. To put this speed into perspective, consider that it only takes 1.3 seconds for the helical engine to cover the vast distance of 240,000 miles to reach the moon. In a mere 12.5 minutes, aspiring colonists, guided by Elon Musk's vision, could arrive at the red planet Mars. For those with more ambitious celestial aspirations, a journey to Neptune, spanning 2.7 billion miles, would take around 4 hours, a feat previously unimaginable. The helical engine promises astonishing speeds and renders interstellar travel more plausible. An illustration of its transformative potential lies in its ability to transport individuals to Proxima Centauri, a star system, in a relatively brief 4-year span, a stark contrast to the daunting prospect of tens of thousands of years with conventional methods. What makes the helical speed engine even more groundbreaking is its practicality. The origins of the concept of the helical engine can be traced back to Dr. Burns of NASA Marshall Space Flight Center, who shared his vision in a published document on NASA's website. Dr. Burns proposed an in-space engine that eliminates the need for refueling, making it suitable for long-term satellite station maintenance. Moreover, this engine could propel spaceships to nearly the speed of light, enabling intergalactic travel. One of the engine's revolutionary aspects is its departure from traditional rocket fuel requirements. Dr. Burns's innovative approach leverages sophisticated particle accelerators, like those found in Europe's Large Hadron Collider, to overcome the practical limitations of interstellar travel. By utilizing electromagnets to propel and recycle tiny particles at high speeds, the helical engine harnesses the speed of light to alter mass, paving the way for a more sustainable and efficient era in space exploration. The physics behind the helical engine. The helical engine introduces an innovative design utilizing a helix-shaped tube to generate motion. This tube exhibits the unique capability to advance while rotating on its axis. The engine comprises an elongated cylinder featuring internal walls intricately carved with helical-shaped grooves. These grooves, filled with a manipulable fluid, are organized in a specific pattern. The engine's propulsion mechanism stems from a temperature differential within the cylinder, induced by heating at one end and cooling at the other. This temperature variance results in a pressure differential in the channels, prompting the fluid to flow and apply force in the opposite direction on the cylinder. The resultant push can propel a spacecraft, offering an efficient alternative to traditional engines that rely on pistons for motion. The helical engine's design aims for increased efficiency through its unique approach to generating motion. Dr. Burns further explains the intricacies of the helical engine's operation using a tangible analogy, a ring inside a box equipped with springs on both ends. Applying Newton's principles of motion, he highlights the fundamental idea that every action triggers an equal and opposite reaction. When the ring is propelled in one direction, the box recoils in the opposite direction, creating a bouncing effect as the ring reaches the end of the box. However, the principles shift when the box and ring are in motion at the speed of light. Albert Einstein's theory of relativity comes into play, asserting that at such speeds, the ring's mass increases as it approaches the box's end. This results in a more forceful impact, propelling the ring forward faster. Dr. Burns asserts that this system can achieve speeds up to 99% of the speed of light without contradicting Einstein's theory. However, it's essential to note that this plan challenges traditional physics and diverges from Newton's law of motion. Yet, the practicality of reaching our destination on schedule overshadows these deviations. Dr. Burns proposes that for the system to function optimally, it would require a structure measuring 650 feet in length and 40 feet in width. The energy demand is considerable, with 165 megawatts needed to generate just 1 Newton of push. This power requirement is akin to that of a substantial power plant, emphasizing the substantial effort for a seemingly modest output. It's worth noting, though, that the engine operates in the vacuum of space, where friction is non-existent, mitigating the challenges posed by traditional physical constraints. Humanity's quest for interstellar exploration and multiplanetary survival. Throughout history, the human desire to explore the far reaches of the cosmos has been fueled by the dream of reaching extraterrestrial destinations. This longing stems from the realization that each twinkling star in the night sky is akin to our sun, potentially accompanied by planets and the possibility of life. The astronomical distances, however, pose a formidable challenge. Even with the remarkable speed of NASA's Juno mission, clocking in at 74 kilometers per second or 46 miles per second, it would take over 4,000 years to reach our nearest stellar neighbor, separated by more than 4 light years. The intrinsic human drive for exploration encounters a significant hurdle when faced with the vastness of space. The closest star remains distant, even at the swiftest attainable velocity. In response to this challenge, SpaceX, the commercial space venture founded by Elon Musk, emerged with a mission to facilitate multi-planetary existence. Musk envisions a future where humanity becomes a spacefaring civilization capable of settling on other planets. His rationale extends beyond mere exploration. Musk argues that in the event of a catastrophic event, such as a major asteroid impact on Earth, establishing human colonies on planets like Mars could serve as a crucial safeguard for the survival of our species. Elon Musk, foreseeing the future in 2016, presented two potential trajectories for history: either a final extinction event that keeps humans confined to Earth indefinitely, or the evolution of a multi-planet species. He advocates for the latter, believing it to be the most prudent and resilient path forward for humanity. Elon Musk's Mars vision. Elon Musk's audacious vision to establish a permanent human settlement on Mars has sparked skepticism among many, given the historical reliance on government-led space exploration due to its intricate nature and high costs. However, Musk's unwavering dedication and visionary approach challenge the conventional boundaries of what is deemed feasible. The pivotal component in Musk's grand plan lies in the efficient transportation of people and goods between Earth and the distant red planet, a formidable task given the vast distance of approximately 34 million miles that separates the two celestial bodies. To illustrate this, the recently launched James Webb Space Telescope, positioned a mere 1 million miles from Earth in the Sun's orbit, took a month to reach its destination. Musk's solution to this cosmic challenge is the Starship, a robust spacecraft currently under development by his aerospace company, SpaceX. Despite the Starship's capability for rapid travel compared to existing space technologies, the prospective Mars explorers are still projected to endure a journey lasting at least 5 months. This extended duration in space poses significant health risks, particularly due to the prevalent radiation in deep space, which can prove fatal and render travelers vulnerable, a predicament incongruent with Musk's vision of a self-sustaining society on Mars. Beyond radiation concerns, prolonged exposure to a low-gravity environment during the journey raises additional challenges, significantly impacting bodily muscles. Moreover, the inherent uncertainties of space travel magnify the risks, as any unforeseen complications during the extended voyage could jeopardize the health and safety of the colonists. Time is of the essence for Musk, who faces the daunting task of transporting several tons of essential supplies and equipment before the inaugural Mars expedition. The urgency is further underscored by Musk's ambitious goal of relocating over 1 million people to establish the foundation of a new Martian city within a relatively brief time frame. Despite developing what is touted as the most potent rocket ever, the Starship, Musk continues to explore alternatives for a faster and more efficient mode of interplanetary travel, recognizing the myriad challenges of turning his extraterrestrial aspirations into reality. Can humans travel in space at such high speeds? Despite skepticism about the possibility of space travel at such incredible speeds, Elon Musk remains steadfast in his belief in the capabilities of the helical engine. Why has he chosen to embrace an engine that challenges the laws of physics and potentially propels a vehicle faster than 186,000 miles per hour? What prompted NASA to support Musk's unconventional proposal? And what groundbreaking possibilities could unfold in space if Musk's vision becomes a reality? To address these questions, let's delve into the mechanics of light-speed engines. To surpass the speed of light, it's crucial to understand the behavior of light itself. As light traverses space, it interacts with every atom in its path. Light can be slowed down or even halted without nearby matter. Due to these interactions, the maximum speed at which light can travel through space is 186,000 miles per second. If the goal is to reach a distant star within our lifetime, we must explore alternative routes, as exceeding the speed of light would violate the fundamental laws of physics. Considerations for speed of light travelers. Lastly, before embarking on Musk's Starship, which will use the helical engine, potential travelers must understand the peculiarities of speed of light journeys. Once in motion, you'll outpace light, leading to peculiar distortions in your visual perception. The world behind you will fade into darkness, and time will seemingly freeze, causing clocks to come to a standstill and planets to cease their rotation. On the contrary, the light ahead of you will likely reach you faster than usual, intensifying its brightness, while the light on your side may streak past in a mesmerizing display of colored bands. Expect a significant constriction in your field of vision. However, the potential to venture into deep space outweighs these effects. What are your thoughts on the groundbreaking helical lightspeed engine the USA and Elon Musk revealed? Leave your comments below. Also, like this channel and subscribe to be up to date with the latest contents. Thank you.